The future is approaching faster than you might imagine. These new technologies will alter the way we live, care for our bodies, and assist us in preventing a global catastrophe. Today's technology advances at a rapid rate. There is new technology that will sometimes revolutionize the future every day. In today's video, we are going to find the 12 untold dangers of technology that will impact our future. Before we begin, make sure to subscribe to our channel Future Fuse and also hit those bell icons to get notified whenever we post a new video. Number 1. AI optimized manufacturing. The current state of affairs results in significant energy, resources, and time wasted due to paper and pencil tracking, luck, extensive international travel, and opaque supply chains. Companies that design and build products will quickly adopt cloud-based technologies to aggregate, intelligently transform, and contextually present development and process data from manufacturing lines throughout their supply chains, which will be accelerated in part by the long-term closure of international and regional travel by COVID-19. By 2025, manufacturing lines will be able to continuously optimize towards higher output and product quality levels thanks to the pervasive stream of data and the clever algorithms processing it, reducing overall manufacturing waste by up to 50%. As a result, we will benefit from faster production of higher quality goods at a lower cost to the environment and our wallets. Number 2. Artificial brain implants will restore lost memories. To repair damage from Alzheimer's, strokes, or injuries, it may be possible to replicate small portions of the brain with artificial brain implants by 2030. The recovery of forgotten memories is also part of this. This is so because the devices can mimic the electrochemical signals from the areas like the hippocampus, which is involved in transferring information from short-term to long-term memory. The system would function by effectively replacing damaged brain regions, forecasting what those regions should do at any given moment, and enabling the transmission of brain signals between areas where a void once existed. Artificial brain implants will get better and better at simulating complex brain functions throughout the 2030s and 2040s. Number 3. Human brain simulations could become possible. The exponential growth of data and information technology may allow for the creation of precise models of every component of the human brain and its 100 billion neurons as early as 2025. Although it may be possible to scan and map up the whole human brain down to the level of the individual neurons, it will take much longer to analyze the vast amounts of data it contains and use that to understand how the brain functions fully. Nevertheless, this significant achievement will inspire creative solutions for most brain-related illnesses. It might be helpful for non-biological brain augmentation, controlling virtual objects with brain-computer interfaces, and transferring memories between humans and machines. Number 4. Carbon sequestration will be commonly used in many nations. Due to years of research and development, several new methods will be used to capture and remove carbon dioxide from the air. The planting of artificial trees is one method of carbon sequestration. These artificial trees are thousands of times more effective at capturing carbon dioxide through a filtering system than real trees. They can be positioned in large cities, alongside motorways and other polluted areas, where they can have the most beneficial effects. They come in a variety of shapes. After being drawn from the atmosphere, carbon dioxide in solid form can be used for various tasks, including product manufacturing. However, great care must be exercised to prevent carbon dioxide from being re-released into the atmosphere after recycling it. Number 5. The entire ocean floor will be mapped. As of the recording, less than 10% of the world's ocean floor has been meticulously mapped. Even the Moon, Mars, and other planets' surfaces are now better understood. A project called Seabed 2030, a collaboration between French and Japanese organizations, aims to produce a complete map of the ocean floor by the year 2030. Fleets of automated ships that can travel across oceans would cover millions of square miles as part of the effort, carrying a variety of sensors and other technologies. Thousands of feet below the ocean's surface, these ships sent tethered robots to inspect exciting sights. The project will be finished by 2030. The maps would show locations of shipwrecks, plane crashes, archaeological artifacts, and other exciting areas, as well as the physical structure of the ocean floor in unprecedented detail. Number 6. Natural language processing. NLP focuses on systems that can recognize and comprehend spoken human language. It includes related tasks like translation, speech recognition, and the creation of natural language understanding. NLP systems would be a real improvement because different languages are spoken worldwide. As part of the current NLP research, chatbots that dynamically communicate with people are being created. A crucial component of artificial intelligence is natural language processing. With the aid of lexical, semantic, and synthetic analysis, it assists in determining the user's intent. NLP aims to read, comprehend, and interpret human language. Please subscribe to the channel if you still need to, and do give the video a big thumbs up if you enjoy it. Also turn on the bell icon to receive notifications about upcoming videos. Thank you. Now let's get back to the video. Number 7. Sand batteries. Not every technology advancing our future needs to be complex. Some are straightforward but incredibly powerful. Some Finnish engineers have developed one of these technologies by figuring out how to transform sand into a massive battery. These engineers filled a 4x7 meter steel container with 100 tons of sand. After that, wind and solar energy were used to warm up the sand. A neighborhood energy provider can disperse this heat to warm up nearby buildings. In this manner, power can be stored long term. The entire process is made possible by a theory called resistive heating. Here, the friction of electrical currents heats the material. The electricity passing through them warms sand and any other non-superconductor, producing heat that can be converted into energy. Number 8. Brain-reading robots. The application of brain-reading technology has significantly advanced in recent years and is no longer a sci-fi trope. Researchers at the Swiss Federal Institute of Technology Lausanne, or the EPFL, tested one of the most intriguing and valuable uses that we've seen. These researchers have succeeded in developing a method for tetraplegic patients unable to move their upper or lower body to communicate with the outside world. Their inventions include a robot arm, a brain-computer interface, and a machine learning algorithm. During tests, the robot arm would carry out easy tasks like navigating a barrier. Using an EEG cap, the algorithm would then decipher brain signals and determine when the arm had made a move that the brain had deemed improper, such as moving too close to an obstacle or too quickly. The algorithm can then be modified over time to account for personal preferences and brain signals. Future development could include brain-controlled wheelchairs or devices to help tetraplegic patients. Number 9. 3D printed bones. The 3D printing industry promises everything from low-cost home construction to reasonably priced durable armor, but one of the most intriguing applications of the technology is the creation of 3D printed bones. Tricalcium phosphate, a substance with characteristics similar to those of human bones, is used by the company Ossiform, a specialist in medical 3D printing, to make patient-specific replacements of various bones. It's surprisingly simple to utilize these 3D printed bones. An MRI can be performed in a hospital and sent to Ossiform, which then develops a 3D model of the required patient-specific implant. Once the surgeon approves the design, it can be printed and used during surgery. The use of tricalcium phosphate allows the body to remodel the implants into vascularized bone, which makes the 3D printed bones unique. In other words, they will make it possible for the bone it's replacing to regain its previous functionality. Number 10. Self-healing living concrete. By combining sand, gel, and bacteria, scientists have created what they call living concrete. According to researchers, this building material is more environmentally friendly than concrete, the second most consumed material on Earth after water. It has structural load-bearing capabilities and the ability to self-heal. The University of Colorado Boulder team thinks their work paves the way for development of the future buildings that could heal their own cracks, suck up dangerous toxins from the air, or even glow on command. Number 11. Living robots. One day, tiny hybrid robots made from frog embryonic stem cells might be used to collect microplastic from the oceans or swim around human bodies to specific areas that need medical attention. Joshua Bongard, a computer scientist and robotics specialist at the University of Vermont, who co-developed the millimeter-wide bots known as xenobiotics, said, "These are novel living machines. They are neither conventional robots nor recognized animal species. It belongs to a new category of artifacts, a programmable living organism." And number 12. Artificial neurons on silicon chips. To mimic and replicate the electrical properties of the neurons in our nervous system, scientists have discovered a way to attach artificial neurons to silicon chips. Professor Elaine Nogaret from the University of Bath, who oversaw the project, remarked that up until this point, neurons had been like black boxes, but the team had been unable to crack the open lid and look inside. Because it offers a reliable method to accurately replicate the electrical characteristics of real neurons, our work is paradigm changing. However, considering that our neurons only require 140 nanowatts of power, it is broader than that. This is 1/billionth of the energy needed by a microprocessor, previously used in earlier attempts to create synthetic neurons. Let us know what you think about the impact of technology down in the comment section below. Do you think technology will impact the world in a good or a bad way? Also, don't forget to subscribe to stay up to date about the amazing technologies our future has to offer. Thank you for joining, and we will see you in the next video.